Hi, I'm Tony.
I'm Joro.
I'm Mitko.
I'm Marina.
And I'm Dani. And we're the Wombats of STEP.
For our approach, we decided to split our efforts in two separate directions, or several separate directions. One was to look at the list of different propaganda types and determine some specific features of the data that correspond to each propaganda type, and to handcraft some features for each of them. The other direction was to find some pre-trained language models or word embeddings that can help us encode the semantic context of the data. We had two options there. One was the word language model and the other were the word-to-vec word embeddings. The reason we look at both of them is because we weren't sure we would have the computational power and enough time to actually refine the word model on our data for the current task. So we also tried the word-to-vec embeddings.
While analyzing the data sets, we noticed that propaganda texts tend to be loaded with more emotions than non-propaganda texts. And that's why we use the IPM BlueMix API to extract emotion features. And as you see on the example, this text is loaded with sadness and anger, and usually propaganda texts convey fear and anger. Subjectivity and polarity are also common properties of propaganda texts, and subjective texts are influenced by emotions or opinions. Propaganda texts also contain extreme polarity. They can be either extremely positive or extremely negative.
Finally, we look into the lexical features of the sentences, like punctuation, because exclamation marks or questions within the sentences show questioning of ideas, which is common for propaganda. We also look at the part of speech tags, especially focusing on the usage of personal nouns and adjectives and adverbs, which are correlated to the sentiment and subjectivity of the sentences. We look into the sentiment, whether it is more positive content or more negative content. And the last metric is the readability. We use several well-known readability metrics like flash reading is to measure how complicated sentences are.
BERT is a language model recently published by Google Research Team, and we used it to further enhance the semantic encoding of the sentence. It is like word embeddings, but it captures more context. We used it. We used the pre-trained model given by Google and fine-tuned it for a task by the given dataset. And at the end, we plugged in a classification layer for predicting whether the sentence is propagandistic or not. And as our final solution, we used the stacking ensemble. And each model of this stacking ensemble consists of the feature engineered features that were mentioned above and the MERM model. And with the idea being to encode different representations of the data that are uncorrelated. So the meta-classifier, in our case a logistic regression, a simple one, can model this model basically to understand which model gives better results and to find hidden relation between these models.